So this video is about anti-differentiating e to the power of kx. It's probably one of the easiest things to anti-differentiate, given that e to the x is the derivative of itself. So it's pretty straightforward. So we'll just jump in, have a quick look, and do some examples to make sure that you're really comfortable with doing this anti-differentiating. Okay, so we recall that if the function f of x is e to the kx, then the derivative is just k times e to the kx, so the derivative of whatever's up here in the index. Down there, and then times the original function, e to the kx. So if we reverse that, all we need to do is take into account that we've got this multiplier here, and we divide instead. Okay, so when we're anti-differentiating e to the kx dx, so with respect to x, then that's just going to be 1 over the derivative of whatever this function up here is, and then e to the kx. And don't forget plus c. Okay, must remember that. And that's all there is to it. So we'll jump straight in and have a look at some examples. Okay, so the first one, we're talking about general antiderivatives. That means you need to remember your plus c. We haven't been given boundaries or anything to do your integration between boundaries. Okay, so I'll start over here. Okay, so using our notation, we've got the antiderivative of e to the power of 4x dx, and that is very simply 1/4, so 1 over 4 e to the power of 4x plus c. Okay, so just taking the derivative of that and putting that down as the denominator. Then b, I've got e to the 5x plus 6x dx. Okay, so same thing again. 1 over 5, e to the 5x, and then of course the antiderivative of 6x is 3x squared plus c. Okay, we'll go up here for c. So antiderivative e to the 3x plus 2 dx, so that'll be 1/3 e to the 3x plus 2x plus c, and the last one, just e to the minus x plus e to the x dx, and again it's going to be negative e to the minus x, plus e to the x, it's just its own derivative, and therefore its own antiderivative, plus c. So as you can see, that's probably one of the easiest things to anti-differentiate, just remembering that you need to consider the derivative of the function up here in the index, and then divide by that. And of course, you can always check by going back and differentiating the functions. So if we went here, we wanted to differentiate this function, bring that down, that cancels with the 4, then we end up with e to the 4x, because of course the constant becomes 0, and we get what we started with. Okay, a little worded question. So we've got, if the gradient of the tangent at a point is given by this, and the curve passes through this point, find the equation of the curve. So these sorts of questions, it's sometimes a little bit hard to tease out which is the curve and which is the derivative. Okay, so the gradient of the tangent of a curve, so if we say the curve is f of x, then the gradient is going to be f prime x. So this is our derivative function here. And then the curve, which is the original function, f of x, passes through that point. So you need to be careful that when you start substituting in to find values to be constants, that you're substituting into the right thing. Okay, so what we're going to do is anti-differentiate this. So we've got 5e to the 2x dx. Okay, so if we anti-differentiate that, we get 5 on 2 e to the 2x plus c. And now we want to solve that given that it goes through this point. Okay, so we get 7.5 equals 5e to the 2 times 0 of 2 plus c. Now of course anything to the power of 0 is just 1, so that gives us 5 on 2, 2.5 plus c is 7.5, so therefore c must be 5. And therefore, because it's asked for the equation, it hasn't just asked for finding the constant, it's actually asked for the equation. So the equation of the curve is therefore y equals 5 on 2 e to the 2x plus 5. And that's probably about as complicated as it gets for anything using Euler's number. So that's all we really need to look at with this video, and this is all you need to know. If you're going to anti-differentiate e to the kx, just make sure that you divide by the derivative of this function up here, leave e to the kx by itself, and don't forget plus c.